And yeah, as you just said, I'm going to talk how to discover artisanal and small-scale mining using AI on satellite imagery. And for that, I want to present our ASMSpotter tool, which we at DIDA developed together with the university in Aachen in the scope of an ESA-funded project. And now, as the product is kind of ready, we try to apply it in the real world with our partners, Levin Sources. So first, let me just give a quick overview on what I'm going to touch in this talk. So I will begin with who we are and what ASM actually means and what it actually means in Africa. And then I present our machine learning solution to you, how it's technically working and what the challenges are we are facing in Africa. And the last slide will just be a quick touch about what we achieved so far and where we are headed in the future. So who are we? Some might remember us from the last year's AMLD, where actually Will, one of our machine learning scientists, presented our cloud detection software. And besides Will, there's about 30 other scientists working with us, mostly mathematicians and physicists. And yeah, due to our nature, we are specialized in algorithmic problem solving, and we have a really strong focus in machine learning. And we are also really strongly connected to basic research. So we're presenting, for example, at ICML or here at AMLD. And with our learnings from the basic research, we try to solve also real-world problems. So we have paying customers, and we understand us as a team as like kind of a bridge between research and industry. And also, I want to give a quick shout out to Levin Sources, who are our partners on this ASMSpotter project, who are the experts in the field of artisanal mining. And watch out that we also apply this tool in this like kind of hot topic in a responsible manner. And yeah, let's now jump right into the topic of ASM. So ASM refers to artisanal small-scale mining, which covers like the whole mining process done informally and sometimes illegally by some people or groups of people with sometimes archaic tools like pickaxes or pens to try to get out the minerals needed from the soil. But this can also be semi-mechanized, as in the left-hand side picture. You can see there's some mechanic sieves people are using, and also like generators and pumps to go through the water and the soil, and up to like highly mechanized operations, which then lead kind of devastating traces actually. In the middle image, you can see an aerial view of the Amazon rainforest in Peru. And yeah, all those pits you can see there are actually also contaminated because many times the people are also using chemicals like quicksilver, which is a heavy metal. And so all those pools are kind of intoxicated. And you can imagine if this water also leaks into the agricultural areas, as you can see on the right-hand side in Indonesia, those toxic chemicals also make their way into our food chains, for example, and yeah, are not really nice for the environment. Besides those environmental issues, ASM is also quite difficult in the field of the social problems which it's causing. There probably you have heard of child labor, or yeah, you can imagine also the working conditions are not really nice if you sit in this pile with quicksilver, or also in the tunnels which are collapsing. So all those issues are actually growing together with ASM, which is rising more and more, also due to commodity price increases. So to show you that it's not a niche phenomenon, you can see that nowadays almost like 1/5 of every ounce of gold is coming from such mines. And actually most people working in the mining sector are not employed in official mines, but working in those ASM sites. Of course, also because they're not as automated as large-scale operations. and that it is a hot topic also in Africa. You can see if you look at this map on the right, you can see that especially in the Central African regions, there's loads and loads of people employed in this field. So to have a little bit of a focus also on Africa, I think you all are quite familiar with the example of the cobalt coming from the Democratic Republic of the Congo, as there almost like 2/3 of the whole cobalt mined in the world is coming from this region. It's quite a dependency. So if you look at your mobile phone, there's on average about 6 grams of cobalt contained in this lithium-ion battery. And if you add up those numbers, you can see that about 1 gram of this cobalt in your phone is coming from one of those sites. So somebody in those fields there worked for you to get out this 1 gram. And not only is the world depending strongly on those miners there, but also the miners are depending on the world and the world markets. So fluctuating prices can have actually devastating impacts on the people living off of there. So in those regions, it's not uncommon that whole families are depending on the income of one person working in those mines. And yeah, as all those operations go together with a lot of problems, like, as I mentioned, child labor, there's a big incentive for NGOs and governments to try to formalize those sites to get rules established and to prevent people getting forced to work there, and all this stuff. And if you but look closely, there's also some successful formalization projects. And if you get to the point to formalize a mining site correctly, then it can actually benefit the people, because the mineral riches of the country get then translated into economic stability and help for the people living there. But the big problem which all those interest groups have is that actually there's ASM is kind of like a black box, so it's really hard to get to see into it and to know where it's actually happening, what the drivers are, where it's happening the next. So the number in the top left, the 15 to 30% coming from ASM, is demonstrating that uncertainty. So the nature of ASM makes it really hard to track it and keep up with the pace of change there. And what people usually do to, for example, baseline it and see where it's happening, you send teams on the ground or in the air to observe large areas. But as ASM mining is stretching over whole countries, as you could see, the whole east of the Congo is actually spread out with those ASM sites. It's really, really expensive to do, and a lot of those developing nations can hardly afford to do that. So there's where ML solutions come in handy, because the combination of satellite imagery, which gets much more affordable, much more high quality, and also much more accessible now, you are able to observe really large areas to detect those mines. But without machine learning, it's also still quite a laborious effort to establish those baselines if you go through the data manually. So the trick is that you teach an AI to detect those sites for you on the satellite data. And if you're successful, you can actually use the regular updates of the satellite to establish those baselines much more often and much more, stable, let's say. And if you have that, then you can deduct, for example, the trends pushing ASM, and also establish alarm systems, for example, for environmental protection areas, so that your system notifies you or the people on the ground that there's a problem and they should go check out what's going on there. So to give you an idea of how it's working, we prepared this demo. You can also check it out on the website. You can find the link down there. And here we have an area of interest in Suriname. And the yellow layer represents the 2016 baseline. So that's all the area covered by ASM this year. When you go through the years, you can see how the ASM is expanding. So here in the middle, it's expanding, and also here in the north, where it's next to a nature reserve, you can see how in the recent years, 2019, 2020, it started to encroach on those areas. And this analysis you can do now pretty cheaply with this AI. So how does it work? The technique behind it is called image segmentation. And what you classically use for that is convolutional neural networks. And they're looking at the image and consists of an encoder and a decoder part. And the encoder then extracts the features from the image and relates between them. And then afterwards classifies each pixel of the image as in a category or in another. So in the case of self-driving cars, maybe you've seen it before. For example, on the left, the yellow part is the house, which is then classified as this category. In the case of our ASMSpotter, we have for now 2 cases, which are ASM or no ASM sites. And if you produce this output mask, you can put that over your satellite image and then highlight the minds in this image. And the real power comes then from being able to measure it quantitatively. So you can see, for example, if you compare 2 months, that in this time of the year, your ASM activity grew by so and so much hectares. The architecture we are using is quite a classical one, UNet, which was developed in 2015 for medical image analysis. And now we tried out also different models and found out that UNext, which certainly contains some improvements, for example, more skip connections or also this pyramid pooling. I don't want to get into detail here now. Helps to increase the accuracy of our model. So now, let's come to the training data set. That's the second important ingredient for a neural network. And there, our colleagues from the Aachen University, which are the mining experts, took on the laborious task to label on 15,000 images those mining sites. And to make the model generalize more and apply it to other geographies, you have to then create more small data sets. So we did that for Peru and Guyana. And also one big step we took this year was the migration of our data sets to freely available Sentinel-2 data from ESA. There, the resolution is a little more coarse, but it's still working quite well for South America. So how about applying that now in Africa? There we actually have 2 challenges. The first one is that the climate is a little bit different. So in the DRC, maybe people familiar with remote sensing there know about the haze. So humidity in the air makes the image a little bit disturbed. And so if the model didn't see that before, it has quite a hard time looking through that and analyze the image correctly. The second challenge we are facing is that artisanal mining in Africa looks a little bit different. So in the South American jungle, actually you have those big water pools created in the middle of the jungle. So for a segmentation model, it's quite easy to detect. In the case of Africa, you have much more land uses, for example, maybe stoneworks or agriculture, which can look quite similar on this cross-sentinel image, as you can see here. So this is a thing we have to look into if it will still work. So to tackle those things, we're now relabeling with our partners 11 sources regions in the DRC, and then retrain our model on that. And also we are now using this atmospherically corrected L2A to have the model see this haze more, and then also be able to adapt to that. Another thing we are doing to help policymakers to understand the dynamics of ASM is multi-class labeling. So we are not just labeling now ASM, but also like settlements or agriculture and other land uses. So that was almost the presentation. As the last slide, I have here what we achieved. Yeah, in 2020, we were really happy to receive a Microsoft award, the AI for Earth award. And in the scope of that, we were also invited this year to take part in the Conservation X Labs Accelerator Program, which is meant for the winners of this prize to be able to apply this tool in the real world. So they're helping us with that. Now, on the technical side, we want to include radar imagery in the future, so that, for example, the haze in the Congo or also cloud cover in the Amazon region is less of a problem. So that was the presentation. I hope it was informative. I'm happy for questions. And please, if you know somebody who's interested in piloting in Africa, or yourself you are, please reach out to us. Thanks.
Thank you so much for this insightful presentation. Yes, indeed, this is a great application of machine learning on artisanal mining, and this could help both the people and the environment, which is great. We will move on to the questions, and I see that you have a lot in the audience. So the first one, Wasim is asking, how do you see your project evaluate?
Sorry, how is it evaluated?
No, how do you see the evolution of your project?
Yes. Yeah, as I mentioned in the last slide, so we have those problems. For example, in South America, there's over the rainforest, there's a lot of cloud cover, and especially in Guyana. So regular updates are an issue there. And so radar can help pierce through those clouds because radar penetrates it. So that's a way forward. And also, in Africa, we will try to cover more and more different mining styles. So the network can generalize more and detect on more and more geographies and more types of mineral extraction, for example.
Great. Another question from Wissam. Can you create alerting on top of classification in order to notify the authorities, for instance?
Yes. So this is part of the post-processing, right? So you can have a layer which, for example, counts the difference between one time step and the other, what was detected, and then you can highlight for example, the largest zones where the biggest expansion happened, and then you can just do regular post-processing and then set up an alarm, for example, which notifies then maybe NGOs working in the rainforest.
Great. We are running out of time, so one last question on my side. So you talked about the cloud haziness and how much it can disturb the prediction, make it unstable. Did you use other corrupted data in your training set so that you can make your model more robust to it?
Yeah, actually, we tried to develop a data augmentation algorithm, which then simulates the haze on the images. So if you have like one training image for one certain area, you can then put the haze over it, which you beforehand expected from another image pair. So we tried to do that, but it was apparently not enough. So we have to expand, I think, the training set there. And that's why we are also trying to use now the L2A processing. We didn't use that before because it's only available from 2017 on, and we want to go further back in time. But that is what we're trying now.